So inserting was a little bit easier than deleting. All we're going to do is if the root is equal to null, all we're going to do is say, well, our root is going to be the new node where we pass in key, because there's nothing else in here. So our root is just going to be equal to our key, and then we could return the root. Otherwise, we're going to need to recursively go through this until we hit this base case. So we will have an else if statement, and we're going to say, well, if key is less than our root dot data, we need to go to the left hand side. So we're going to do root dot left is equal to a insert where we're passing in the root dot left, and then we also pass in the key so we can examine both. Otherwise, we're going to go into an else if statement, and then we are going to say that, well, if our root dot data is less than our key, we need to be in the right hand side, so we'll do root dot right is equal to inserts where we're passing in root dot right, if I can spell that correctly, and then we're going to pass in key. So that will be that else if. And then once we're done with all of this, we're going to eventually want to return the root. So we're going to unwind after we do our recursion. Remember, we would go through here and then we would go backwards. And so we would just return the root when we're done here. And that's it for the insertion method. Now we're going to look at printing. And it's kind of long like delete, so we'll just have this break right here. Inside of our printing, we are just going to have a method that will first print everything. This is what this is right here that we made in the main method. And now we can create the method right here. Scroll all the way down, and hopefully it did not print out what we wanted, but print it out right here instead. So we can just cut this, and then we will come down underneath our insert and paste it right here. So this is printing. We have a public void toString. And in our toString, we're going to have a sysout.println, where we say the tree in pre-order is this. Now we're going to need a method, and we'll call it preorder because that's the name. It's super simple. And then we're going to do a sysout, and then we're going to say, well, we need the tree, and actually I'll do 2 breaks for lines, and we're going to do tree in order. And then we're going to need a method here. We're going to do in order, and then we're going to pass in the root. And then we're just going to do the same thing. Now we print. We are going to have 2 lines just for syntax, or for not syntax, but for nice output. And we're going to have tree by level, where we pass in the level. And then we want to have a level method, and we're going to pass in the root for this. And this is going to print out all the levels. We're going to hover over all these and create them. First thing that I want to do is hover over level because it creates them. The last you click is first. So we're going to create all of these. And then let's start with preorder first. Now this isn't in the instructions, but it is known, and it is in some notes, that preorder, we visit the root, we traverse the left tree, and then we traverse the right subtree. So I'll copy all of this, and then I'm going to paste it in the documentation that we will have right here. So we're going to visit the root, we're going to traverse the left subtree, and then traverse the right subtree. First, we obviously need to see if our root is null or not. So as long as our root is not equal to null, and this is really our base case, so we're going to be writing inside of our base case. And after we do our base case, we're going to unwind, and we're not going to do anything. So this is really tail, not, I forgot what the other one was, but basically we stop once we hit the end of recursion, and then when we're going back, we are not doing anything. So we're going to do a sysout.print, not print line, but just print, because we want to print these all in the same line. And the first thing I'm going to do is print the root dot data. And then we are going to have a comma like this. And if we wanted to, we can make it a little bit fancier so that there's not a comma at the very last thing, but I'm just going to keep it simple and just visit the root. And then we need to traverse the left subtree. We're doing this in recursion. So we're going to do pre-order, where we pass in, and I'm going to change these root 2's just into root. Again, there's no naming conflict here because this takes precedence over our private root that we made earlier in this class. So since it takes precedence, we're going to do pre-order, and we're going to just pass in the root.left because, well, we need to traverse the left subtree. And then we're going to do the same thing but for the right. So pre-order, and then we're going to do root.right. Now we have our pre-order done. Let's look at in order. So in order, we need to traverse the left subtree, visit the root, and then traverse the right subtree. So it's going to be slightly different. In order, traversing the left subtree, we're going to call in order. This is going to be recursive. Oh, but make sure we need to do this in our if statement, our base case, if our root does not equal to null. We're going to be in here, and we're going to do in order. And then in our order, we're going to look through the left first. So we're going to do root.left. We're then going to visit the root. So we're going to do sysout.println, and then we're going to have our root.data. And then we're also going to need to append this. And then we're lastly going to visit the right. So we're going to do in order, and we're passing in root.right. So that is going to be that code. Now we need to print the level. Dealing with the level, we're going to need some helper methods for this because what we're doing is we need to find the maximum depth of our tree, so kind of the lowest point, and then we're going to need to print each level until we reach that depth. So we are going to need to find our max depth in a helper method. Then we are going to print our actual level in another helper method. So we'll need two helper methods for this, and that will make more sense when we start coding it. So first we're going to store the actual depth in an integer. So we'll do int depth, and we'll say is equal to max depth, where we are going to pass in, and I don't want to say root for this, especially because we are looking at different levels. So I'm going to call this leaf, and I'll pass in leaf plus 1. And so we'll hover over this, and we're going to need to create our max depth method. Before we do this, let's continue a little bit on with our level. So we know we have multiple levels we need to look at, so we should use a for loop. We'll do for int level is equal to 1, and then we're going to run this as long as level is less than or equal to the actual depth, and then we're going to do level plus plus. We will be inside of our for loop. Now we need to print our level. So printing the level, we're just going to, like I said, make a method for it, and we are going to go through all of our levels. We could do it inside of here, but it might be easier again to just make it into a method. So in our method, we want to pass in our leaf that we are looking at, and then we need to pass in our level. And yeah, we'll just change this back to root, just to stay consistent with all the other times that we've called it root. I'm just looking at that, and I prefer it to be root. So now we can say, okay, well, we're going to print the level, and we're passing in our root, and we're going to pass in the actual level that we're at. So we have our root, we have our level. We're first going to print out the root, obviously, and then we're going to print out left to right, left to right, left to right, and so on and so forth until we get to the last level. And every time we run this for loop, because remember, we're just going to print out the first level, we're going to come back from this method, and we're going to go in the for loop again, and then go to the next level. We're going to want to make a new line, so we'll just do sysout.println to print a new line. We'll hover over print level, click create print level. We're going to cut this and paste it down here, and then I'll just get rid of this extra space right here. And so this is our level. Wrote out some Java documentation just to keep things neat, changing this to root. And now we can start with our max depth. Inside of our max depth, we are going to first need to see if our leaf is equal to null. And then if it is, we're going to return a -1. So if leaf is equal to null, we're going to return a -1. Now, this should be root. I remember I changed it from leaf to root. And then from here, we're just going to fall into an else statement because, well, if it doesn't equal to -1, then we are going to need to do some other stuff. And we're going to recursively go through this. We need to recursively see and add on to our depth. So what we're going to do is increment our left depth. But we need to do this recursively because we need to also kind of search through our tree. So we'll do int, we'll call it left depth, and we'll set this equal to max depth, where we passing in leaf dot, or not leaf, sorry, passing in root dot left. And that is the recursion for that. We're going to need the same thing for the right as well, so we'll do int right depth is equal to max depth, where we are passing in our root dot right. And once we do this, we need to see if our left depth or the right depth is greater. So if the left depth is greater than our right depth, we're going to be inside of here, and then we are going to return the left depth plus 1. Remember, we're returning an integer. So once we do all of this recursion, the left side, we're going to do all of the right recursion. And then we're going to basically add these together every time it hits the base. We're going to fall into this if statement. We're going to add 1, and then we're eventually going to see which is greater, and then we're going to return whichever that is. So we're going to return if our right, okay, well that was actually kind of a bad explanation. These if-else statements, this else statement is going to be like this in reverse, is basically to see if our left depth is greater than our right depth. We need to get the greatest one because, well, that's where our tree is longest, and that's what matters. So we'll say else, and remember this is if our left depth is less than our right depth. We are going to return the right depth plus 1 because it's greater. So that is the max depth